Hello and welcome to my Nintendo 3DS video 3 in loading 3D models. So let's get into it. So today's topics, I'll show you a breakdown of what the Wavefront 3D format is, the OBJ files. These are the files which I'll be exporting from Blender, and they are the format that my conversion tool uses, and they will convert the OBJ file into an array of unsigned and signed shorts for us to easily load in models. So first off, before I go any further, let's open up and see the demo. So I'll talk us through what we have here. So the scene has a mock level, if you like, for a game. And if we look around here, we'll see various characters. We have some moving characters here. We have a Gumba model which I've created. We have a cow which I've loaded from the models resource and converted. Then we have Junior here, Junior Bowser, which is another character that I've converted and loaded in. And then if we move away here and you have a look around the scene, we have some scenery. And this is what's known as a skybox. So we have a skybox with a large seamless texture. If we move around our scene, the sky doesn't go away. And then I also have a SkySphere as well. So you can use the left and right buttons to change the cube for a sphere and see what that looks like. And then if we have a look around here, we have some star models. And then we have some sprites in the trees here. And then we have some other characters which are meant to be sprites as well. I'll get to those. So the dog here, the reason why I've put it blue on the outline is so that you can see it here. So this is actually a semi, a half sphere, if you like, or a dome, and these point at the player's camera, and they give like a kind of 3D effect for the 2D image. And then there is the girl character here. She is also using a dome as well. And then we have the barn and the apartment building here. So I'll show you how these were created in a bit and exported, and then I'll show you the how I made the level in LibreSprite, and then we'll go over converting a model and replacing one of the apartments here with the new model. And then I'll jump into the code and then we'll go through it that way. So first off, so as you remember from the previous videos, this is how everything kind of works. We need vertex shaders to do all of that. Oh yeah, I'll also go over the skyboxes and the SkySphere as well, how I made them. It's literally just a case of reversing the normals which results in the order that the faces for the model are drawn in being reversed. So let's talk about the Wavefront OBJ file format. So the good thing about this format is its files are basically text files. So I'll bring across a simple OBJ model here, and then to open that, use a Notepad if you're on Windows. If you're on Linux or Mac, then you'll need another text editor to open that with. Then if you open up an OBJ file, you should be presented with something like this. The key things we are interested in are these ones here, which begin the line with a V, which stands for vertex position or vector. Then we have our UV coordinates here, which start with VT, and then we have our vertex normals below here with VN. So all of these here are unique points which make up the model, and then the description of the model is here. So basically these three groups here. So first off, when you export your OBJ file, you need to make sure that you have normals and texture coordinates. So you will need to assign a material to it in Blender. I'll show you that in a bit. And then each of these three groups here, the first number refers to the vertex position. The second number refers to the texture coordinate. And then the third is the normal. And then that basically is one textured vertex. And then each of these three make one triangle. So if you export your model and it doesn't have these groups of three here, then you've not created triangles. You might have quads or some other odd shape. That will not work. Everything needs to be converted to triangles. And then basically you draw these in order going down. So that's how these look like. So I could just load a load of these, but it's easier to convert these into the format that LibNDS uses, which is what I will talk about now. So first off, I'll show you the what the format looks like. In fact, I may as well open up the project. So once we've exported and converted these models, they basically look like this in the end. This is the number of textured verts. So as you'll see, it's all in hexadecimal here. So the first three numbers here are the position converted to fixed point numbers. Then we have two texture coordinates and then three numbers for the normals. So basically those floats are all converted into these fixed point compact assembly values here. or hexadecimal numbers, sorry. So I will now talk about what fixed point numbers are basically. So let's get that into view. I'll open another text file to try and explain this. So before floating point numbers were standard on computers, a way to represent floating point values was to take a standard data type number. So for example, an unsigned char or a U8 has 8 bits, and then depending on the accuracy that you want in your floating point numbers, all you do is you set aside some of these bits to be the whole number, and then you set aside the other bits to be the fraction part. So you could do this. So the first 4 numbers here would be the whole value, so that would give you a value between 0 and 15 there. And then the other side of the decimal place here, these 4 bits would then be the fraction parts. So the easiest way to think of it is all these numbers here are basically shifted to the left there, and then basically anything on this ends up being kind of like 1 divided by whatever this is here. So that first bit there is always 0.5. That one there would be 0.25, and then basically these just divide by 2. So as these are 1 times to the power of 2 going up, these are to the power of 2 going down, but they basically end up being like 0.5, 0.25, 0.125. So if you wanted to have positive and negative numbers here on your fixed point value, you would use a signed char, so that would be just a char there, and then what you would do is you would have this basically. So that would be 1.3.4 as your fixed point format. That first byte indicates that it's signed, so it can be positive or negative. But now what you have is you only have a value between 0 and 7 there. But you have a higher range of fractional parts. So basically this just allows you to use what you already have to work with, like ints, shorts, chars, which are relatively fast to use, and then you kind of used shift values, or you shift bits up and down to allow you to convert between them. So on the DS, on LibNDS, they had 3 fixed point formats for holding the different data types associated with a textured vertex. So the texture coordinates were in 1.3.12 or 4.12. So they had like one sign bit, 3 whole number, and then 12 fractional parts. And then the normals had 1, 5, 10, and the vertex position coordinates had 1, 11, 4. So what I did was I took the lowest value here, which is 1, 3, 12, and I just used that for converting all of these. So basically I took the all of the floats from the OBJ files, and then I just converted them to the 1, 3, 12 format here. What that means is the model sizes can't be any greater than 7 basically. So 7 to minus 7. So if we have a look in here, the format I called it was fixed 16. And it is actually that there. And then we have a few functions here which basically convert it to and from a float. But I will jump into that in a moment. So first off, let's jump into Blender, and I'll go over some of the 3D models first. So one of the first things I kind of was doing. So some of this is the same as my Nintendo 64 models. So the first thing I did for the Nintendo 64 was I wanted to see how much detail normal models for the games actually used. We can obviously use a lot more for the 3DS, so there is that. So one thing when you have or open up Blender, sometimes it's best to have the statistics here so you can see how many triangles a model actually has. And then what I did was, so this was the model that I created myself, which was based on this one here. So as you can see, that's their, this is their texture for the N64, and theirs looks slightly different to mine. And as you can see, mine's got like a better sort of body on it, whereas if you actually look at this one here, its body is actually a plane, which is wait, if I can just get around it a minute. This would cause issues drawing that because it's only a plane here. And then another thing you can do here as well is show face orientation. So what this does is anything red means it will not be viewable unless you turn off cull facing. Usually everything that is blue is what you see. Anything that's red is hidden. And then one thing to note here is whenever you actually export anything, it should always be scale 1 and the location should always be zeroed. I believe I created like another version of mine where I basically, yeah, this is the one here. This is the one I actually exported. So as you can see here, it's slightly smaller. Its scale is set to 1. So once you've finished scaling these things, what you should do is you should press Control and A, and then you apply scale. And then if its location is wrong, you need to make sure that that's sorted out as well, and make sure there's no rotation on it as well. the yellow dot in the center there, that's its origin or its center of rotation. Just undo that. So this one here, basically I joined all of these parts together here. So if I separate these a moment, so now what you'll see is this this part here is now separate. So what you would do is with this one here, select all of it, right click and then join, and that's how you connect parts together if you don't already know that. So this is one of the models I exported. We'll hide that one and then I'll show you the others and the purpose for these. So this is the dog dome. So what we have, the reason why I did this is it's quite good to have sprites be domes, as it kind of gives them a more sort of a 3D kind of feel, although it's hard to sort of notice that as there aren't many lights in the scene. So all this is if I go into edit mode there, this is just a low poly dome, and then you see that the center of rotation is in the actual center there. But then if you look around that, you'll see there's no faces on the back. So you need to make sure that this is actually a sprite. And then texturing this was fairly straightforward. So if I go into UV mode here, select the dog sprite here. So you see all of these faces here are centered inside. And then I'll show you how I made that now. So we'll hide that one. So Shift and A to add a new mesh, and then I believe it was a UV sphere. We'll leave this as detailed as this here, and then if you press 1 on your numpad, in fact we want to delete the back of it, so if you press Control and 1 to get to the back view there, and then go select it, go into edit mode, and then select all of that, and that should select all of the back faces of this sphere here. And just have a look around, make sure, yeah, it didn't select all of the faces there. Look. So holding Shift, make sure you select all of those. Go into flat shading so we can see it better. You see that it didn't get those at the top there. So now we've got those, we can delete those with X and then faces. Now what we want to do is select everything, and then we turn those into triangles, so triangulate faces. Now what you need to do is we want to add a material to this so that we can texture it. So if you come down onto the materials property, go on to new, and then you go on to this base color button here, click that, go on to image texture, and then we can click on new. No, sorry, not new. Open one up, and then come to a location where you've got your images. So let's see, where are we here? I don't want to be in there. Okay, these are not a good example. I'll use one of them that I already have in here then. So this assigns the my girl texture to this sphere here, but as you can see, it hasn't applied it very well. So what we need to do is go into UV editing mode, and then we need to get the front view and then move this into view here, and then you can use this to select the correct image here. So this is our image, and as you can see here, we have all of our faces on the wrong part here. So the easiest way to do UV editing, which I find, is navigate your camera, orientate your camera to the view that you want. So I'll select the front view here, and then right click, and then unwrap from view. If you do it to bounds as well, then this will fill the full shape, the full image with your faces of the model here. So this looks fine here. If we go back to object mode here, and then shade smooth, and there you go. That's the easiest way to unwrap parts of your model there. So there's our new dome. And then if you're happy with the origin here, then that would be good to export there. However, one thing that's useful to have is the origin at the bottom center. So let's do that now. So you see now, if I come to the front view here, now the reason we might want the origin to be at the bottom here is it makes it easier to have as a character in your scene, because then they would already kind of be on the floor. So whatever value the floor of your world was, you could just have that as the Y coordinate of your model. So to set the origin now, what you would do is right click and then set origin to 3D cursor. However, you need to make sure your 3D cursor is at the origin of the scene, which would, as this is local coordinate space here, the cursor here is at 0, 0. However, you could move the cursor around anywhere you want. However, it's best to set it to world origin, which is 0, 0 there. And then this one would be good to export now. So you'd then export as a wave object, selection only, and then make sure you have triangulate faces and keep vertex order, and then you would just give it a name there to export. So that's how you create a character. And this is a star which is in the scene there. It has a back face to it as well. As you can see, its origin is at the center. So I'll now open up the file with some of the other characters in, and then I'll tell you, point you to a site where you can use some game models already created just for reference purposes. So I'll open another one here. So in this file here we have some of the buildings. So if I come down here, we also have let's see if I can find them here. Here's a model that I created recently using some textures that I got from the textures resource, which is a site I will go to in a minute and show you. And then in here as well is the apartment building, which is fairly straightforward. This was just made from a cube, and then if I hide that, I'll quickly show you, as it takes no time at all. So Shift and A will add a cube, put that to 1, and then all I did was go into edit mode, and then there's inset faces here, so make sure you're in faces mode here. I selected the top face. Let's go into this so you can see it better. Selected the top face, and then I inset faces here. I usually find it better to use the shortcut keys, so I does that. So then once the face is inset, then press G and Z to move it up. And there you go, that was the apartment building made. And then all I did was select all the faces, then triangulate the faces, and then time to add in a texture. So I have the apartment building in here somewhere. There it is. And then at the start, obviously everything's all mucked up. So go into UV editing again. And then each of these faces was unwrapped individually. So on the left hand here we have the texture coordinate window. So the easiest way to get this working is select that face, right click, and then project from view to bounds. And then all I did then was, with this selected, press S to scale, and then free, and then you'll see here that the texture coordinate is, the texture has now been wrapped around, so we have it repeating 3 times on each face. And then for the roof here, all I did was unwrap that and then just move it up the top to some of this. Or another thing you can do is scale it, press 0, and then everything's compact to 1 pixel. And then that will just give you a single color. And then another thing in here that you should have sometimes as well is snap the coordinates in there to pixels, which is useful sometimes if you export a model and the texture coordinates aren't quite aligned to a pixel. You can end up with a color bleeding in from other parts of your texture. And then all I did was did that for each face, and then that gives you the building like this one here. So one of the other characters that I downloaded here is Junior Bowser. So this is what he looks like after I have formatted him. So what I will do now is I'll take you to the site where I got him from, and then I will show you what you have to work with once you download these files, because you will need to do some work with them. They don't come ready to use, basically. So this was another sort of working of him that I did here. So the site where I got him from, a useful site for you to go to. So if you go to the Spriters resource first, so you see here they also have the models resource and the textures resource and the sounds resource. So all of these are really good for finding examples to work from, so you can get an idea of how much detail models for that console had, so you can match that or lower it. So we'll go to the models resource, and then the Bowser model was for 3DS, and then I got him from, I believe it was Mario Party Island Tour, and there you go. So we click on him there. This is what the model looks like, and then if you download the asset, and then the other thing that I got from here as well is I believe it was from Mario Kart 7, and then it was the Daisy Hills texture. So that gives you a kind of view what it will look like there, but there's obviously more stuff in there. And then you can use these to download textures to sort of see how they textured parts of their models. So one thing to note is you might need to enable Blender to load additional formats, as they're not set up by default. And then the way to do that is go into Edit and then Preferences, and then if you scroll down here to the Import Export section here, so some formats that are frequently used is the FBX format, and then you might need to enable the Wavefront OBJ format if that's not already an option for you. And then there's also the Collada format, which is the DAE format. I'm guessing that must be a default one already enabled, as I don't see it as an import export option. So if we navigate to where you downloaded your models, you should end up with a zip file. You see here I have a number of them, and then if you have a look in that zip file, you'll see there's a few different textures. Normally, if you're lucky, it will just be one texture, as we will only be working with single textures. And then this here is the actual model itself. And then these various parts here are obviously native 3DS formats, which I do not know. So to import your model into File, Import, and in our case we've seen that it's a DAE file. Then navigate to your downloads. And then you'll see that there's a number of stuff associated with it here. So it will basically come in as it will say armature usually, or something of that. And then there's all kinds of other stuff associated with it. There's like bones, poses, and then there's usually loads of different other parts. And they're all kind of compacted into one. So if you move some of these around, you'll see the various parts. So you'll see the eyes are separate, the hands are separate, and then there's also bones associated to it. So you want to get rid of these bones. And as soon as you do that, the model itself is then split into various parts. So you'll then need to rotate it, and then position parts to the origin. So here's the body here with no eyes. So I believe everything needs to be rotated by 90. There you go, that corrected the eyes there. They're in place. And then we will sort out the hands as well. So that looks good there. So what we need to do is to join the hands to the rest of the body here. So select the part you want to join to the other parts, and then join. So we've selected the eyes there, I don't know if you can see that. And then we select the rest of the model and then join them. And then you'll see once you join them, what will happen is the textures will change. And that's because sometimes some of these model parts might be using a different texture. And then what we need to do is to look at the dimensions here. That's far too high, so we need to scale them down. So usually I'll try and get things in the range of 1. There we go. Get rid of those hands there. And then we will zoom back in on them there. So you'll see here we have a weird scale and a weird rotation. So what you need to do then is we need to fix those. So Control and A, and then click Scale. Now scale is recalibrated, if you like. And now we need to remove the rotations. Let's do the same with rotation. And the reason why that is you don't want to export your model with a rotation already on it or a different scale, because otherwise when you try and load it in, it will all look all mangled, and that's because you've exported it with a wrong scale, or maybe a location value still on it, or a rotation. And then, like I said, this is using two different textures here, and we cannot have that. We want everything to be on the same texture. So I'll show you what I did with mine. This is the one to use. So you see I've got different hands on this one. And then what I did was I basically took the two textures and then merged them into one. So if I open up the image here, what I did was I found a part of Junior's texture map which was not used, or parts of it which not visible, and then I copied the eye. So if I come back to the downloads and show you again in a minute, you see here we had the eye image here. So all I did was I copied this part here and then just pasted it onto this part of the texture map here, which I found was not used. And then what I did, so if we went to UV editing here, go into edit mode, UV editing, and then this shows you where various parts of the model are assigned. So if we orientate ourselves around here, so if you click on one part of the face and press L, then that will link the other mesh parts with it. So you see here, here's the eye here. So we could drag this around somewhere else. So now see he's got a yellow eye there. Or a green eye there. Now it might be that the eyes won't be mapped. So in which case what you would do is orientate your camera to a good view of the eye, say there. Select everything, right click, and then unwrap from view. And then that will match what you're seeing through this camera viewport here. And then you can just drag this over to the eye and then scale it down, and then make sure all of these points fit in the eye part here. So I'll do the same again with this eye here. Use the camera to orientate, and then we'll select everything here, project from view, move it to where we want it, and then scale it down. And that looks good. And that's pretty much how I kind of sorted him out. So you'll need to do that with the hands and the eyes. So where was the last one? Okay, so now I will go back to the, not that one, this one here. So that's how you need to work on any models that you import. They will be in various states. You'll need a single texture for them, and you need them to be for this project here. They need to be one mesh only. So now what I'll demonstrate is how to actually do everything, how to import a new model, how to import its texture, and how to place it on our scene. So this one here uses the texture I downloaded. So if we go to downloads here and then Daisy Hills, these are those texture files here. So what I did was I had a look in here, and then I decided this bit would look good, and then this bit would look good, and then I took both of these parts out and created my own image. And these are the parts which I put in here. So I rotated bits around here, and then I assigned them to individual parts of the model faces here. So if I select everything with A there, go into UV editing, you can see how it works out. Where using the method I showed you before. So one of the things I also sometimes do to make things easier is if you delete half of the model, so if we went to wireform with Shift and Z, select the front view, make sure you're on faces, and then when you've got half the model to work with, as long as it's going to be symmetry, which in the case of this model it was, you literally just unwrap key face parts here. So you'll see these faces here were unwrapped and put on this part here, and then this face here was then mapped to the window up here, and then the roof is pretty much just mapped to this one here, and then these faces are just both assigned to this window part here, and then the whole part here for the back face. And then once you've got everything set up, make sure you're in object mode, and then go to the modifier properties here, add modifier, and then mirror modifier, and then make sure it's the x-axis is selected, flip and clipping is also ticked, and then the second half is all sorted out for you. So if you go into edit mode here, you'll see this is the half which is actually being mirrored, and then this is what's going to be projected from that. And then when you're happy, go onto there, apply that, And then before you do that, before you do anything else, go into edit mode, select vertex, press A to select all of them, and then right click and then merge vertices by distance. And the reason why you do that with your models before you kind of export them is to make sure there are no vertex overlapping each other, which sometimes happens. If they're sort of scaled down low, they could be right next to each other, but you might not be visible from the viewport. And then when you export them, you're obviously exporting extra data, and then that might show up, making the models corrupted when you import them into your own scene. So now we've got a model here, so let's export that. Also note that the scale is 1, there's no rotations. The orientation for this is at the center there. However, this is going to be replacing one of the apartment buildings. So let's just double check where the origin is with that one. Okay, that's center as well. Another thing to note as well is you'll see that there's no bottom face on here. That's another thing I tend to do after looking at what was done with the old consoles. Is there's no point having extra faces in your model if they're not going to be seen, so get rid of them. So for example, we'll hide that. So in the apartment building here, you can see that there's a bottom on it. There is absolutely no point to having that. So if we go into edit mode here, select both those faces and get rid of them. And as you can see there, that saved us 2 extra triangles. So let's come back to our house now. Make sure it's at location 0, 0, which it isn't at the moment. So we will, okay, it is. Make sure you're in object mode. Make sure this is selected. Go into file and then export, and we want OBJ. Make sure you select selection only and then leave these as the default. So this should be -Z is forward and Y is up. And then select triangulate faces and keep vertex order. So then we will export that. Nothing more to see there. And then let's close out some of this here. So what we need now is the side by side 2 windows here. So on the right side, come to where your models are. So this is the one we're interested in here, house2.obj. And then come to where the conversion tool is, the OBJ tool. So the download will have either the source code for you to build this here, or if you're on Windows, you can download the exe file and then use that as it is, which is, I believe it was exported in 32-bit format, so it will run on 32-bit or 64-bit machines, or you can build it yourself. It will need you to have the SDL2 library already configured on your machine to build it, as that's what it relies on. And then this should just end up with an exe file on Windows, or this file here. on Linux and Mac, and then it's just a case of just drag it across and then select where you want it. And then if everything's fine, it'll be blue here, otherwise you'll get an error and it goes green afterwards. So we've got that now. So now what you need is we also need the need to navigate to your project, and then in the graphics folder we need to add our new texture. So I've already copied it in here. So now I will talk about the level map. So this is an easy way for you to arrange your 3D scenes. So what we have is you can basically think of your whole scene as being created from tiles. So if you take that into consideration, then you can basically end up with something like this here. So this is our level size, so it's 16 by 16 tiles, and then each of these pixel colors here can be considered to be each of these pixel colors here can be considered to be a level object. So if I open up our code here on the left hand side and I come to the LevelManager and I'll scroll down here, so each of these enumerations here correspond to one of these colors here in this level map. So the purple color here, or magenta, that's actually just a spacing, as some of the models are larger than one tile. The gumbas here, which are the red colors, they are 2 by 2 tiles, and the buildings are 3 by 3 tiles. So you basically construct your scene in here. Note that the white color here is the player tile, and this just allows you to easily envision what the level should look like. If your scene consists of multiple heights, then you could have multiple levels, slices if you like, and they would kind of represent Y coordinate stacking. Hopefully that kind of makes sense. Basically, if you're going to have a few sort of different heights, you could have a few different slices representing those. Obviously that's only going to be good for relatively simple scenes, but that's an easy way to get going with all of this. And then one thing to note here is the greys here are the two barns. The dark grey is the apartment building or the flats, and the light grey is the barn. And you'll see the blue colour is the cow, which is centred in the barns. And then once you have everything laid out, save that. And then what you want to do is to use my other tool, which you might have already been using already, which is the DS to tile tool. And this is just to convert the level image into bytes for us. So we'll be selecting 8-bit bitmap mode for that, and then drag your new level in there, and then save that. So now we have those. Make sure you have an enumeration for whatever model it is you're going to use. And then we need to add our new model. So let's go into the graphics define file here. And then we need a signed short, so let's call it house 2. So you have a signed short for the vertexes and an unsigned short for the indices. So if you remember from the last video, all of the model parts were basically float arrays. So we're using the same format, only this time we are converting everything from let's go into models here. Only this time, instead of using the floats and the indices that we used before, we are now using these models which we load in. So navigate to where is it, that one? No. Here we go. So open that in a text file, and then we want to add those in. So there's our models added in. So we now need to also add in our new texture names. So in the image assets folder here, so also in here as well as our image here, we also need a T3X file. So here's the one that I created here. So open those in a text file, and all you'll see is it literally just consists of this So there's your new texture name, and then just leave that as FRGBA auto. And then what you need to do is to add in that name there, bond text2, and then underscore t3x.h. So I think that's almost everything. So now we need to add in our new level as well. So I'll just add it before this. Just copy and paste that in there. So now that we have those in there, we now need to reference these in our main. So we need to load in our texture here, and I believe it was bond 2. And then you also need to pass in the size of it as well. And then we need to know the width and height of it. So that was 256. And we don't need UV wrap in there. So that's our new texture added. We now need to add in our model. So the new functions for our mesh manager is to add in S16. So let's save that and rebuild everything. Make sure we've got no errors. Oh, forgot a comma there. That's okay, so that's built fine. The only thing we need now is to add that into the LevelManager code, as this replaces so this is, where are we? I have a function for adding in static models here, so this will need updating here. This is probably going to be the easiest way to sort of do this. Okay, I've not defined that as well, so another thing to make sure you have as well is our mesh IDs in here. And also give it a texture ID as well. So these IDs here, they basically align up with the order we're adding meshes here and the order we are adding textures here. So with that done now, so that should sort that out. And then we also have to correct this as well. Where are we? Apartments. Basically pass across what type the tile is. So I'll rush this here, get it through, and then I'll talk about this some more once everything's fine. I basically created like divided the model types up. So if we load this in now, okay, that means I need to increase the amount of meshes there. So I'll increase that. I probably need to increase the amount of textures as well, so we'll do that as well. Good that showed up in the video. That means the error trap functions are actually working, which is my own sort of method of debugging. There we go. Now you can see if I rotate around, that's probably far too big, but that's fine. That's fine. It should be the same height as the original barn. The reason why I'm having issues controlling it is because the controls are obviously mapped to keys. This would be fine if I was actually doing this on the real 3DS. So that's fine. That demonstrates everything there. So I could change the height there, but I will leave that as it is now. Let's jump into the code so that I can try and keep this video relatively short. So what I've demonstrated there is how you can easily load in models into Blender, convert them into a format which we can use on the 3DS. And the load-in method basically just works off of the same as what was done in the previous video. So let's go over the format quickly. So the from the previous video, there's still the previous function where you could pass in the textured vert pointer. So the textured verts, they are still being used. As you see here, this is the model format we are using to draw our triangles. And then the additional method here, the add S16. So you see here we're still passing the indices in here, but we don't need to add the indices count, as this is specified in the various arrays. These are the first values in these arrays here. So what's actually happening behind the scenes here is when you pass in these arrays, we are creating a new mesh data buffer. And then what we're doing is we are creating some temporary holding values here, UVs, vertex positions and normals, and then we take the numbers from the vertex first. So you see here the first three numbers we take are converted to floats for the X, Y and Z positions. Then we take the two UVs and then we take the three normal values. And then all of these are basically, those are in fixed point format, the 1, 3, 12. Those are the positions, those two are the UVs, and these three are the normals. This format I find to be nice and compact, which is why I use it. Otherwise you would have to create huge arrays of floats to accomplish the same thing, unless you were loading them specifically from the SD card as you needed them. Whereas I find this to be more elegant. And then what's happening is it takes 3 floats, 3 UVs, 3 normals, and then it basically converts them into a textured vert using the set vert function there. And then behind the scenes here we have the 3 positions, the 3 texture coordinates and the normals as before. This just iterates over the array to extract everything from the model data you pass in, and then does exactly the same as the previous buffer add function. And then if you look in here, this is how these are basically converted. So the fixed 16 is basically an alias for a short. There you go. So to convert that to a float, you basically skip over the fraction parts. So the F32 is basically a float. So to convert the fixed 16 to float, which is what's happening here, you basically divide that by the fraction parts shifted by 12. And then this is basically the same, this is exactly the same function, the same function twice. Three times even. So this is how you basically, to convert a float to a fixed 16, you basically shift the whole parts by 12, and then to convert it back, you take the number, convert it to a float, and then you divide it by the 1 to the power of 12, which is, I believe it's 4096. Let's double check that. Yeah, there you go. So you basically, by shifting it by that, you basically put the whole numbers into the end. So that's that there. So let me see, what else do we want to talk about here? Some key parts. The bounding sphere and cube. So I'll quickly go over those a moment. Let me see, where were they? Are they in here? Nope. Here we go. So this is how I constructed the bounding models. So the first thing to note is the face orientation. So what you need to do is you need to, if I hide that a moment, and then we'll add another one in. So here's your standard cube. When you create it, you'll see that if you've got the face orientation selected, it's blue. So what you need to do is go into edit mode, select all the faces, go into mesh, and then recalculate that inside. Now what that means is if you are actually inside here, then the faces will then be visible. And that's exactly what I did. I basically, you change the normals to reflect the other way, and then you can actually be inside these. The next tricky part is to then get the textures. I will upload this one as well, this OBJ, this Blender file here as well. If you go into UV editing here, this is the whole image here. So what I had to do was I found this image, and then what you have to do with these is you need to make them seamless. So one way to do that is to select an image and then basically double the width of it, and then copy one part and flip it horizontally, which is what I did here. That'll probably make it probably easier for me to show you that, so I will. So here's the image here. And then the actual image is this here. So what you do is you copy that, double the size of it, paste that in, and then you flip that horizontally. And now what you should have is this image, this side here should match this side here. But it'll be a case of find a large image and then find a part of it you're happy with, and then you'll have to do this here to work with it, and then you'll then have to sort of maybe fix some of the alignment parts here. So one way you can fix some issues is the blur tool can be used to kind of fix some things. Or another way could be to try and mix up some bits and pieces where there's a seam. Or you could also use the GIMP image editor to sort of smudge things. There's like a tool for that as well. I'll quickly show you that. So if you zoom into places where there's like a noise, and then this tool here, select the smudge tool, and then select like a small brush, and then scale that right down. And then what you can do is you can kind of smudge things into a kind of common pattern. You can kind of use this to erase stuff as well. So you want to kind of just use the colours which are already there so that it appears seamless. So what we've done here is kind of erase part of whatever was there before. And then copy that back out, back into LibreSprite, and then save that. And then you'll have to keep going backwards and forwards in Blender to try and figure out where things should be. And what you need is you need all three of these faces. Sorry, you need all 6 of the faces aligned. So if I come in here a minute, so you can see what I've actually done. So we'll come to the front face first. You'll see the front face is here in the image. Then the right face is here, and you need to make sure that these can almost appear to be sort of connected. And then the back face is bolted on here, and then the front face is obviously bolted on the other side. And then what you need to do is to do the top face and the bottom face. All I did was I scaled them to 0 and selected a colour which would appear to be sort of common. If you had like a larger image, you could try and select a part of this which appeared to connect with everything else. The problem you'll have is trying to find an image at the bottom part which seamlessly connects to all of the other faces in here. And then obviously I did the same for the sky as well above. So the sky on the top, again, that's a single pixel point here. Depending on how noisy the sky is, you might be able to get away with a selection in here. There are like proper, you might be able to find some proper cube maps for you to use online. But this is the easiest way I've found to kind of create your own. And then if I show the sky sphere, which is this one here, again, this is exactly the same to some degree as the cube method. The only difference is what you kind of do is again, you make sure that all of the normals are calculated inside. And then if we select everything here, so I probably should have made this higher detail really. And if you go into UV editing here, this kind of did it all for me. As long as when you create it, you click on enable UVs. So if I come back out of there, we'll hide this, and then we'll make a higher detail one. So Shift and A, Mesh, UV Sphere, and then let's ramp it up a bit. And what you need to do now, once you've created that, is to go into materials, add a new material, and then a new image, and then we will select the sky sphere, and you'll see that it's already mapped the whole surface there for us. As you can see, that one looks a lot better. And then we'll need to recalculate the normals inside. And then make sure the faces are also triangulated as well. And then this has already sort of done a good job for us here. Of course, you could kind of do some of this yourself if you wanted to assign individual parts to this. I would recommend deleting half of it and then just navigating the camera around and unwrapping individual parts like I showed before. So that's how they were created. And then let's talk about some of the LevelManager stuff here. This is probably the more interesting stuff. So you'll see here the level width and height. level tile sizes are 8 in size, and then I give some heights to the barns and apartments, and then some sizes for different things. The Gumba sort of models have a row and a yaw value associated to them, and then the sprites are their own thing, and then the stars, and then the static models. So there's some different model types there, just used for reference for our models. And then some simple methods here. The collision boxes are not used in this demo. All what's used is the LevelManager initialize, update and draw. And then the initialize thing here just constructs the levels from the level data here. So it basically just goes through all these numbers here and then spits out the model types in here. So you'll see there's a list and a list counter for each of the types. There's an animation strip for the sprite characters, and the cows are classed as Gumbas as well in here. And all we do for these are basically little constructors for the different model types. Nothing too special about any of it, to be honest with you. If you've followed any of my previous videos, it all kind of looks very similar. In the LevelManager initialization bits here, that just constructs a level based on the tile types. The thing that makes the Gumbas and the cows more interesting is in the update function here. We have a tick timer which basically changes the animation frames for the sprites. It also rotates there's a global rotate value for the stars, and it updates the Gumbas and sprites in here. The Gumbas, basically we rotate them on the y-axis and the x-axis as well. And then the draw functions here are where the various parts are here. Basically everything is kind of mapped to, we have like an empty 3D model struct which is filled from parts of the mesh, or rather the model types here. Yeah, there you go. The yaw is pumped into the Y angle, and then the Z angle is the row value. All very straightforward there. What an additional thing in here is in Scene 3D now we have the sprite structure is no longer considered just to be a flat plane anymore. It can now take a mesh value and a texture value, and then there's a point at camera boolean, and then you need to call draw sprite batch once you've finished adding all your sprites. And then what happens there is the sprites are all sorted automatically for you here by distance. So if they have any transparent parts, they'll all be correctly arranged. That's all done for you now. Yeah, and that's everything for this video. I am going to look to make a game for the next video. I'm also doing the same for the N64, so I'll look to tie both of the games together. So the options are an Invaders style game, or a Breakout style bat and ball game, or the Plant Blitz game, which are made for the Master System but in 3D. So those are your three options there. Let me know in the comments which one you think I should make, and the one which has the most votes will be what I will make on the N64 and 3DS. Right, thanks for watching. If you have any questions, let me know in the comments below, and I will catch you in the next video. Thanks for watching.